Alright, in this video we'll be examining Riemann sum. We'll be examining how to use the traditional method to find the area of the curve, and we'll be solving the left and the right endpoint of Riemann sum. So let's quickly dive into the video. So we start by considering a function x squared plus 1. Now, the function f of x can also be written as y is equals to x squared plus 1, since we know that y is still the same thing as f of x. Now, the graph of the function is a parabolic graph, and it is facing upward. Now, since the parabolic graph is facing upward, you notice that the graph is not starting from the midpoint. So we assume that this graph is starting at a particular point of 1, so it is not starting from the endpoint. But what we are going to do is we are going to be considering only the right hand side of the graph, or the right hand side of the function. Now, our primary objective is to find the area of the shaded region of the graph. Now, since you can see that the shaded region of the graph is shaded from point x-axis of 0 to point x-axis of 2. So we want to find the area of this graph using Riemann sum and using the traditional method of integration. Then at the end of the day, we are going to compare the relationship between our respective results. So that is our major aim of this video, and this same function. Now, the manual way of finding the area of this given curve, the curve is area equals integral of a to b f of x dx. So we are integrating from a particular region of that same function. So that is, we are finding the antiderivative of the graph. So now, since we already know that the point is from a to b, which is a is 0, and the extreme point, which is 2. So we solve the integral by putting a as 0 and b to be equals to 2 and f of x to be x squared plus 1. And by inserting this, we simplify our integral. And now do not forget, this is a definite integral we are dealing with, and so it simply means that it has a boundary from 0 to 2, and f of x is x squared plus 1. Now, when we solve the integral, when you integrate x squared, you are going to have x raised to power 3 divided by 3 over 3. And when you integrate 1, the answer for 1 is x. Integral of 1 is x. Now, we insert our boundary from 0 to 2. We add, anywhere we see x, we are going to put 2, and we subtract it by imputing the value of 0 as well. So we put 2, that's 2 raised to power 3 over 3 plus 2, minus we put 0 raised to power 3 over 3 plus 0, and by simplification we have 8 over 3 plus 2 over 7, and our answer is 14 over 3, approximately 4.67. So this is the answer for the area of the curve using the manual or the traditional method. So we want to use Riemann sum to compare our solution. So let's use Riemann sum. So the Riemann sum is an alternative method we use in solving the area of a curve or of a given function. So since we are focusing on the right hand of the graph or of the parabola now, and the boundary is given from 0 to 2, it simply means that we have the height of the graph and the width of the graph. So we have from 0.2, and we have, let's assume that the graph is splitted. We are splitting it into 4 different parts. As you can see under the curve, we are splitting the curve into 4 different parts: curve 1, curve 2, curve 3, and curve 4. Now, the height is the function, and the length or the width is the change in x. That's the delta s. Now, if we want to find the area of the given curve, we have to use the Riemann sum. That is, we take the summation of both the length and the height. That is, both the length of the x-axis and that of the y-axis. So the x-axis is summation of is delta x, and the y-axis, which is the function itself, is f of xi. Now you notice that the function is the graph is divided into 4 different parts. So we introduce I equals to 1 to n, where I is 1, 2, 3, and 4, and so on. Do you get it now? And now don't forget our ranges is from 0 to 2. So we are using the Riemann sum to evaluate the area of the curve. Now don't forget, I said the graph is split into 4 parts. So, and since we have the change in x to be 0 to 2, it simply means that there are other parameters that is within the range of 0 and 2. And you can see that the first one is 0.5, then to 1, then to 1.5, then to 2. That is, when you divide the range between 0 and 1 by 2, you have 0.5. And similarly, between 1 and 2, you have 1.5. So these are the range. And why are we having it like that? Because it's already initially stated that we have 4 different rectangle that will be putting into consideration. So it means that the value for n is going to be 4. So you have 0.5 down to 2 or we have 0, 0.5, 1, 1.52. But regardless of the problem you are dealing with, you should have in mind that you must use 4 values. Now we have the area. We can find the area using the left endpoint, we can find the area using the right endpoint, and we can find the area using the middle endpoint or the midpoint. Now, irrespective of the side of area that you are finding, you must make sure that the value of n that you will use is going to be what? 4. So let's take note of that. So let's solve the area of the curve from the left endpoint. And don't forget that this is the formula that we'll be using to find the area of the curve. It is the Riemann sum. So a equals to summation of change in x multiplied by f of x. This is the formula that we are using, where f of x is the function that is given, and delta s. Now delta s is going to be b minus a over n. That's the formula for delta s, b minus a over n. So our f of x equals x squared plus 1, and our boundary is 0, 2. Our a is 0, our b is 2, and our n is equals to 4, because we splitted the graph into 4 different parts. And b minus a, that's 2 minus 0 over 4, that's 0.5. Now we are going to do something. We are going to split the the rectangle into 4 parts. You see, we have 0 and 0.5. Between 0 and 1, we have 0.5. Between 1 and 2, we have 1.5. So we've splitted the rectangle into 4 different parts. Now we want to find the area of the left midpoint, area of the midpoint, and area of the right midpoint. So these are the 3 things we are finding, and after we find them, we are going to compare it with the first solution, the traditional method that we use in finding the area of the curve, and see the difference between them. Now, if you look at delta x, I said it's b minus a over n. What is n? N is 4. Remember, the curve is split into 4 different parts. A is 0 and b is 2, as we've already known. So it means that our delta s is going to be 0.5. Now, our f of x is going to be all of the functions. Don't forget, the function is started from 0, 1 over 2, 1, and 1.5. Now, we are picking these numbers. We are picking 0, 1 over 2, 1, and 1.5 because we are finding the area of the left endpoint. We are picking 0, 1 over 2, 1, and 1.5. Remember, there are 4 in numbers because we are finding the area of the left endpoint. Now, f of 0 means anywhere you see x in the function, you are going to put 0. F of 1 over 2 means anywhere you see x, you are going to put 1 over 2. F of 1 means anywhere you see 1, you are going to put 1. And the last one, anywhere you see 1.5, you are going to put 1.5. So by simplification, we have f of 0 to be 1, f of 1 over 2 to be 1.25, f of 1 to be 2, f of 1.5 to be 3.25. So we add everything together, multiply by 0.5, and our answer is 3.75. Now, the 3.75 is the area of the left endpoint. When you compare it to the manual method or the traditional method for finding area, you see that it is lesser. It is far, far lesser than the answer that we got. The former answer that we got when we used the manual method was 4.67. Now, the answer that we have now is 3.75. So there is a large difference between the two of them because we are finding the area of the left endpoint. Now let's find the area of the right endpoint and compare our solution. So we want to find the area of the curve from the right endpoint. So you see, now the numbers that we are going to be picking, 0 is not inclusive again because we are picking from the right endpoint. So it's going to be 0.5, 1, 1.5, and 2. Remember, when we're using left endpoint, we started from 0. When you are using 1 point from the right endpoint, you skip the 0 and move to the next one, and by simplification we have 5.75, and this one is overvalued compared to our answer. Our manual answer was 4.67, the other one was 3 point something. You can see this one is above, the other one was far below. You get it now? Now we want to find the area of the midpoint itself now and compare our answer. So we have the area of the midpoint, and you see the functions that we are picking now. We are picking 1 over 4, 0.75, and 1.25 and 1.75. How do we come about those values? How we come about those values is that the 1 over 4, remember the previous one, we use the numbers that are within. Now we are moving the midpoint. Our extreme focus is going to be on all of the numbers that is between 0 and 2. Now don't forget, our numbers that we have, it ranges from 0, 0.5, 1, 1.5, and 2. So in order to get the middle endpoint for the function, what you are going to do is the 0.5, 0 plus 0.5 divided by 2, you get 1 over 4, which is 0.25 as well. 1.5 plus 1 divided by 2, you have 0.75. Similarly, you add the next number and divide it by 2, you are going to get 1.25. And the last two numbers, you are going to get 1.75. So when you put 1 over 4 back into the function, you get 1.0.625. Similarly, for other values of f, you get 1.5 and so on. And when you add everything up and multiply with 0.5, you are going to get 4.625. And if you look at 4.625 and the first answer that we got using the traditional method for finding the area, you will see that it is similar. They look so closer to each other. So this is the Riemann sum for finding the area of a curve. So you can compare your answers. We have the area of the midpoint, area of the left end point, and the area of the right end point. So these are the three things you will be doing. So in summary, the area of the midpoint is so efficient and so accurate and so close with the manual method of solving the area of the curve. So this is where we stop for this video. Other videos will be coming up on Riemann sum and more applications. So if you've not subscribed to this channel, kindly do so. Kindly click on the subscription button and also like the video. Thank you.